planet from the Sun in our solar system. It is an ice giant and is mostly made of flowing icy materials above a solid core. Its atmosphere contains hydrogen, helium, and methane. Uranus has a thick atmosphere with a complex layered cloud structure and has the lowest minimum temperature of 49 K, -224 degrees Celsius, -371 degrees Fahrenheit, out of all solar system's planets. It has a marked axial tilt of 97.8 degrees with a retrograde rotation rate of 17 hours. This means that in an 84 Earth years orbital period around the Sun, its poles get around 42 years of continuous sunlight, followed by 42 years of continuous darkness. Uranus has the third largest diameter and fourth largest mass among the solar system's planets. The temperature of Uranus varies drastically between the core and the atmosphere. According to NASA, the average temperature of Uranus is -195 degrees Celsius, -320 degrees Fahrenheit. The coldest temperature ever measured in the solar system was on Uranus, which was -224.2 degrees Celsius, -371.56 degrees Fahrenheit. Uranus' atmosphere is predominantly made up of hydrogen, 82.5%, and helium, 15.2%. The planet's atmosphere also contains methane, 2.3%, which gives it its characteristic blue-green color. Uranus' atmosphere is layered, with the troposphere being the densest layer and extending 30 miles, 50 kilometers, from the surface of the planet. The temperature in the troposphere ranges from -243 degrees Fahrenheit, -153 degrees Celsius, to -370 -218 C, making it the coldest atmosphere in the solar system. The atmosphere also contains traces of hydrocarbons and ices made up of water, ammonia, and possibly methane. The atmosphere of Uranus is composed primarily of hydrogen. At depth, it is significantly enriched in volatiles, dubbed ices, such as water, ammonia, and methane. The opposite is true for the upper atmosphere, which contains very few gases heavier than hydrogen and helium due to its low temperature. The Uranian atmosphere can be divided into 5 main layers: the troposphere, between altitudes of -350 kilometers and pressures from 100 to 0.1 bar, the stratosphere, spanning altitudes between 50 and 4,000 kilometers and pressures of between 0.1 and 10-10 bar, and the hot thermosphere, and exosphere, extending from an altitude of 4,056 kilometers to several Uranian radii from the nominal surface at 1 bar pressure. Unlike Earth's atmosphere, Uranus's atmosphere has no mesosphere. The troposphere hosts 4 cloud layers: methane clouds at about 1.2 bar, hydrogen sulfide and ammonia clouds at 3 to 10 bar, ammonium hydrosulfide clouds at 20 to 40 bar, and finally water clouds below 50 bar. Only the upper 2 cloud layers have been observed directly, the deeper clouds remain speculative. Above the clouds lie several tenuous layers of photochemical haze. Discrete bright tropospheric clouds are rare on Uranus, probably due to sluggish convection in the planet's interior. Nevertheless, observations of such clouds were used to measure the planet's zonal winds, which are remarkably fast with speeds up to 240 meters per second. Little is known about the Uranian atmosphere, as to date only one spacecraft, Voyager 2, which passed by the planet in 1986, obtained some valuable compositional data. The Uranus orbiter and probe is scheduled to launch in 2031, arriving at Uranus in 2044. Its primary science objectives include a detailed study of Uranus' atmosphere. The distance between Earth and Uranus varies depending on their positions in their respective orbits. According to Space.com, the closest Uranus and Earth can get to each other is 1.6 billion miles, 2.6 billion kilometers, while at their farthest, they are separated by 1.98 billion miles, 3.2 billion kilometers. Uranus has 27 known moons. Most of these moons are named after characters from the works of William Shakespeare and Alexander Pope. The moons are divided into 3 groups: 13 inner moons, 5 major moons and 9 irregular moons. The 5 major moons are Ariel, Umbriel, Titania, Oberon, and Miranda. Uranus has a complex ring system that is intermediate in complexity between the more extensive set around Saturn and the simpler systems around Jupiter and Neptune. The rings of Uranus were discovered on March 10, 1977, by James L. Elliott, Edward W. Dunning, and Jessica Mink. By 1977, 9 distinct rings were identified. 2 additional rings were discovered in 1986 in images taken by the Voyager 2 spacecraft, and 2 outer rings were found in 2003 to 2005 in Hubble Space Telescope photos. In the order of increasing distance from the planet, the 13 known rings are designated 1986 Utua/Zeta, 6, 5, 4, Alpha, Beta, Eta, Gamma, Delta, Lambda, Epsilon, Nu and Nu-1. Their radii range from about 38,000 km for the 1986 Utua/Zeta ring to about 98,000 km for the Mu ring. The majority of Uranus's rings are opaque and only a few kilometers wide. The rings are extremely dark. The bond albedo of the ring's particles does not exceed 2%. They are probably composed of water ice with the addition of some dark radiation-processed organics. Some rings are optically thin. The broad and faint 1986 Utua/Zeta, Nu and Nu rings are made of small dust particles, while the narrow and faint Lambda ring also contains larger bodies. Thanks for watching.